We're going over the specifications and the general components of the MS460. So this is a 2-cycle, 2-stroke motor with a single piston. It is a 1.42 inch stroke and a 2.05 inch bore. The RPMs of this motor is 13,500 on the high end or full throttle. While it's idling, it should be at 2,500 RPMs. Without fuel, bar oil, chain, or bar, it weighs 15 pounds. With all those components combined, it weighs 21 pounds. It's a 91 octane fuel with a 50-to-1 2-cycle mix ratio. The components of the chainsaw, starting from the rear to the front, I'm just going to go over the brief overview of them, and then we'll talk about the specifications further later. So here, starting in the rear, where the throttle meets the handle, you have a throttle interlock, which is a safety feature. You have the throttle. You have right here, we have different selectors for the carburetor. To the bottom, we have to interlock the throttle all the way down, locking it in place. You have full choke. To get to half choke, it's a 1-click up to half choke, and then you have to click the throttle interlock with the throttle together to get to run. Lastly, all the way up is stop. Coming to this side, we have 3 holes and this rubber boot that has an inlet to our carburetor, to the high, to the low, and to the idle adjustments. Not recommended that we adjust these. This is a full wrap bar for our hand placement in different positions. This is our bar cover plate, bar nuts, dogs, bar, our chain. This is a 20-inch bar. There are 72 drive links, 36 cutting teeth, and we'll talk about more specifics on this on another video. In the front here, we have our muffler and our muffler protector. This is our chain brake. On top, we have a decompression switch. This is our pull cord assembly. And then we have, the rear is going to be our 50-to-1 2-cycle mix, which it contains 27.1 ounces. And then in the front, we have our bar oil. Our bar oil is an 11-ounce tank. On the bottom, we have our chip deflector, which is damaged, but it's to protect for any material to hit us. And then here we have an adjustment to adjust the amount of bar oil that's going to be delivered to the bar itself, right here. So to make any motor run well, we need to have good air, good spark, and good fuel. So I'm going to be talking about the air component first. So when working with the chainsaw and opening up the air box, it's good practice to always go to our selector switch, push it all the way down, and make sure that we close our butterfly valve. And I'll talk about that in a second. So opening up our air box, we want to make sure that it's clean and clear. Here we have our air filter. With the air filter, there's 2 different types. This is the newer style air filter. It's called the HD2. And this is the older style air filter. Older style air filter has a rubber band filter and then an internal filter with a sponge. To clean these components, still recommends that we just take the band off and we smack them on a hard surface, knocking out any of debris that's clogging the air filter. We want to make sure that we can look up into the sun and that we can see some light coming through, showing that there's adequate airflow that will be able to go through. The one component where people will commonly make a mistake is getting an air compressor and applying any type of compressed air into the air filter. Here we have something called a burp shield. This burp shield is a piece of plastic that's after the air filter. You want to remove it, clean it. If there's any type of debris, The design for the burp shield is that when we start the saw, which is beyond this, is the carburetor. If there's any type of burp or fuel, it'll be caught before it gets into the air filter. We want to have our air filter clean. So having this clean in the interior is a good thing to always check. And it says top here, so this should always be facing upwards in the top fashion. The reason why it's a good practice to always put your saw into full choke when opening up the air box is because it's going to close that butterfly valve. Closing the butterfly valve prevents any type of debris from going into the carburetor or even beyond that into our cylinder. That's the major components of the air box. So next we'll be talking about the electrical component and how to get the electrical current from the flywheel to the spark plug. So the spark plug is located above the air box right here, and we have the spark plug boot. So in order to remove that, you just pull, remove the boot. Here we have access to our spark plug. Here's our boot. In order to show the component, I have to remove the flywheel. So here we have the pull cord assembly. We have 4 torque screws that we need to remove. Three of the same size, and one's a little bit longer. That one's attached to the chain brake. Here we have our pull cord assembly. There's a few components that I like to show. When you pull the pull cord assembly, these components go outward. They attach to the notches here on the flywheel, which grab on and rotate the flywheel in a circular fashion. In turn, there is a shaft that goes interior and then connects upward with the piston. And as the flywheel turns, it creates the piston to go up and down motion. Attached here is something called a magneto. It's attached to the chainsaw, and on the flywheel itself, there is a magnet that is mounted. It's right there, and it's mounted onto the flywheel. As the flywheel rotates, there's a slight gap in between the magneto and that magnet, and as it spins, it creates an electric-magnetic energy, converts it into enough volts to draw up through the cord into the spark plug boot and delivering the adequate electricity to the spark plug itself. We're going to be talking about the fuel component of the chainsaw. So towards the rear, we have the fuel container. Our fuel tank here has a quarter turn cap, lift up, quarter turn, out, and on the quarter turn cap we have either a blue or a black gasket that needs to be in place so that we do not have any leaks. Inside contains our fuel. Any 2-cycle fuel should have some type of coloration, either blue, green, red, showing that there is oil and providing us a visual indicator that there is oil, that's not just straight gas. So inside the container we have our pickup body or our hose, and then we have a fuel filter. This is what the fuel filter looks like, and attached on this end is the hose. If we ever needed to change this, we use a little piece of baling wire, create an S hook, and fish it out of the tank, being cognizant that we don't want to rip that hose. We pull it out, remove the fuel filter, replace it with a new one. So while we start the chainsaw and create compression through the flywheel on our pull cord assembly, so when we pull, we're going to draw energy, creating the piston to go up and down, creating a vacuum, pulling the fuel from the fuel tank up the line to the carburetor, mixing with the air, and creating the proper mixture for ignition. Now I'll be talking about the bar cover plate and the components that are underneath here. So here we have the bar cover plate. It's held on by 2 bar nuts. You need your scrunch, the open end, bigger size of the... So to remove the bar nuts, put your scrunch right here, reach over, and now my hands are free from the dogs. I create a little pressure here. So if I was to slip, I'm only slipping here and not gonna hit my hands here. So you can put them here. remove your bar and chain. The bar cover has a few components to it. Here we have a chip guard, so when we're cutting material, it deflects the chips downward instead of on us. We have, these are called dogs. They're mainly used in the wildland or in timber operations, so you can dog into a material, creating leverage, creating straight cuts. Like I said, it's mainly for the wildland, cutting big trees. Here are two components for us to look for to make sure that they are there. These are nylon chain guides. It's important that they are in place. And while we do our maintenance, we want to remove them. So using your finger or using a flathead screwdriver, we could pop them off, set them aside clean, but making sure that they get put back in the appropriate fashion. So putting them back and pushing them in place. The interior of the saw, we have a few components. Here I'm gonna work on the clutch drum and the components that are making it held together. So first we have something called the E-clip. The E-clip is holding all the components together. It's a key component here. In order to remove it, put your flathead screwdriver in there. So here we have the washer, then we have the E-clip. The E-clip sits down and you can see that the washer has a beveled end to it. We want to make sure that when we replace it, we want to have the beveled end facing up. So remove the washer. And then we have a sprocket. Remove the sprocket. The sprocket has a total of 7 teeth. Total of 7 teeth. What we're looking here for any type of damaging is any type of shiny metal. Any shiny metal, it shows receding of the sprocket, and once the gap here starts to shrink, we want to remove it and replace it with a new one. Beyond this point, we have our clutch drum cover. The clutch drum cover commonly will have buildup material on the inside, so with a rag, we can wipe it clean and keep this interior portion clean. And now we have our needle cage bearing. Needle cage bearing, we also want to wipe it with a clean rag and make sure that there's no debris in the cage, allowing for them to spin freely. Here we have our clutch. So our clutch consists of 3 springs, showing that they're not loose and that they're holding the clutch tight. So when the clutch is rotating at approximately 3,000 RPMs, the clutch will centrifugally open and it will grab on the inside of our clutch drum. And when it opens, it'll grab on the clutch drum as it rotates, which will allow our bar and chain to start rotating. So here we have something called the oiler plate. In order to remove the oiler plate and do our maintenance, we want to remove this pan head screw. By removing this, we'll be able to take off our oiler plate. Remove the oiler plate. We'll clean any gunk that's in here for maintenance. This pan-headed screw, we can remove that to remove the chain tensioner. This screw right here is to adjust the amount of tension in the chain. This hole right here is where the oiler pumps the oil into the bar, allowing for lubrication. Go ahead. So once we remove the oiler plate, there's a screw here, remove those. And we're getting access to our chain brake assembly. So taking this plastic piece off here. This is our chain brake assembly. The assembly starts down here, the brake wraps around And through this mechanism, our clutch drum now is allowed to spin. There's a gap in between the chain brake and the clutch drum. It's loose. Due to inertia or manual application of the chain brake, it'll squeeze that clutch drum and not allow it to rotate anymore, which will in turn not allow our chain to move forward. Now we'll reassemble the saw. So we replaced the needle cage bearing. Here on our clutch drum, we see there's a notch. So this notch, it's gonna seat down over the oiler. So when this rotates, when it's rotating, it hits the oil pump, and then the oil pump turns, goes to the oil reservoir, which pumps oil up through the discharge and into our bar. When replacing it, we need to put it over the clutch assembly, go down, and then when it seats, we know that it has seated properly. I'll be going over the bar and the maintenance, looking for defects, things of that nature. Whenever I get a bar, when I'm doing my maintenance, I'm gonna spray it down with some type of degreaser, give it a good wipe down. While I'm doing this, I could be looking for any defects. Starting at the top, we have a sprocket here, making sure that it rotates and that the rivets that are holding it together are all intact, both sides, and that this tip is mounted with all the rivets and they're intact. Also looking, there's something called mushrooming. So the bar comes out and it's just slowly tapered to the tip. Over years of use, the metal will start to taper towards the tip due to large amounts of use, maybe some over tight chain. If you see some bluish in color, that's indicative of heating. So too tight of a chain, not enough oil on the bar. And when that happens, the metal will start to flay outwards because it becomes hot. So in order to, you can feel with your finger if it's sharp, it doesn't feel flush. It should feel flush like that. If it's tapered out because it's overheated, we can bring that down just for good bar maintenance. We can come to a flat surface using a flat file, placing it down in a flat area and creating a little bit of force in a fashion like that, just knocking down any of that excess metal. So do it to both sides, make it nice and even. Another thing that I would do to clean this bar, you always have a scrunch nearby. At the top of the sprocket, you want to put the scrunch in, working it all the way back down. You never want to work it from the back to the front because you're going to move all the gunk into the tip. So you want to pull it down. So another key thing to look at here on your bar is this is all your components of this bar. So pitch, gauge, and drive links, how many drive links there are for the appropriate specifications for this bar. And then we have a hole here, and then reverse, we have a hole here. These holes right here, the little hole there and the little hole there, that is where the oil is going to get pumped into our bar, and it's located on both sides so that the bar could be operated in both positions. Putting the chain back on the bar. Does not matter which position the bar is in. I always start at the top. Top of the sprocket, seat it all the way down. And at this position, I need to determine whether it's gonna go this way or this way. This is crucial. We always have to have what we call the rakers in the front and the cutting tooth in the back. So this would be the appropriate fashion. If we were to rotate it, now we have the rakers in the back and the cutting tooth in the front, which is wrong. So replacing the bar, I have the appropriate configuration, get my scrunch. I want to rotate a couple turns back, moving that chain tensioner, loosening it to make it easier for me to get it in my slot here. I want to put the chain behind the sprocket and get it seated in the sprocket, work my bar to the front, and then this is the key part here. So I have it into the sprocket, seated, and I have it seated in my chain tensioner. At this point, hold a little pressure there, grab your scrunch, and give it the same amount of turns that you did when you loosened it up. So just another good turn like that, and it should hold in place. Now I can release a little pressure. There's a little bend there, but it's gonna hold. Your cover, put it over the top, and seat it. Get your back bar nut, hand tight, just like that. Nice and loose. So the way that I would tension a chain is there's always going to be, when your bar nuts are loose, there will be play in your bar. In order to make an adjustment to your chain tensioner, you have to have the bar nuts loose. So if you see there's a little bit of play here, whenever tightening up the chain, I want to create a little tension upwards, holding it in an up fashion. That's the way that it's designed, is to have a slight angle in the bar pitch. I put the tip of the bar on an object, and now I can see this gap here. I'm trying to close this gap just so it comes right connecting. I don't want it too tight, and I don't want it loose. So with one hand here, I'm going to start to tighten. And now it's seated. It's kind of loose when I touch it, but I'm okay with that. So I adjusted it, right? Now I'm gonna run the chain with my hand, and then I'm gonna check it again. Anytime you make an adjustment to your chain tensioner, I always suggest running the chain and re-examining. It resets it, and it will confirm what you did is how you like it. So at this point, I like the tension of the chain. And now I started to tighten my bar nuts. I'm gonna recheck. Sometimes when you tighten up the bar nuts, it'll also tighten up your chain slightly. So you want to double check that you still like the tension of the chain. And now we've got to the point where it's hand tight. Well, we need to crank these down, because when this motor is running, we do not want these bar nuts to come off. So we want them very tight. So in order to prevent myself from tightening here and pushing really hard and slipping and putting my knuckles right into the dogs and gashing up my hands, we could put our scrunch towards the bottom and force downwards. So if we do miss, we're not going to put our hands into the dogs. And we're still creating the pressure here, so we have that angle. Tight, tight. And now you can see the bar creates that pitch upwards, just how we wanted it. You can verify as well. So a good proper chain tension should not be any slack down here, just by hanging. And you should be able to grab the chain and freely move it forward. If there's any type of resistance or you have to actually create force to move that chain, your chain is too tight. Loosen the bolts, loosen the chain tension, maybe a quarter turn, spin it, put it on the tip, and check it again, then tighten. If you have your bar nuts tight and you're adjusting the tension, it's not gonna do anything. It's not gonna allow the change that you made is not gonna go in effect until these bar nuts are moved. So you have to loosen up the bar nuts, then loosen up your chain tension or tighten up your chain tension, and then tighten up your bar nuts. So after maintaining your saw, taking it all apart, putting it back together, we need to verify that it's in operating condition. So I'm gonna start the saw, different ways of starting the saw. There's the old way of putting it on the ground, starting it, putting it in between your legs and pulling in this fashion, having control of the saw. And then there's the drop start method. So drop start method, we're gonna forcefully drop down the saw and pull a pull cart assembly towards you. And if the saw was to start, at least when we're drop starting, we're putting the saw away from us. If we were to drop start it like this, the bar would be close to our legs. But drop starting away from us is a safe operation. Whenever you're starting the saw, we need to decompress the decompression switch and put it in the full choke if the saw is cold. So I push the decompression switch, push the throttle in our lock, and push your selector knob all the way down. I'm gonna put it in the full choke position since the saw is cold. I'm gonna pull approximately 3 pulls, and I'm listening and I'm feeling for that resistance, or also known as a pop. And then when that happens, that means the fuel is made to the carburetor, and then I can flip my toggle switch to 3/4 or half choke, and then hot start it. So 1, 2, so I got a pop there at 2. And then without pushing the throttle, I'm just gonna click the switch up 1, and I'm in half choke. At this position, I know that when this starts, it's gonna be a hot start, which means that the blade is gonna be spinning, the chain's gonna be spinning. In order to make that chain stop, I have to come to the throttle trigger and click it, and it'll put it back into idle mode. Now it's idle. So since my saw's already been running, I'm gonna put it into half choke position. Put it in half choke, I know it's gonna hot start, and I'm gonna demonstrate the drop start method. After I have the saw running, I'm gonna point the tip of my bar to the ground, and I'm gonna give it full throttle. I'm looking on the ground for thrown bar oil. It's an indicator that the bar and chain are getting properly lubricated through the oiling process. A common mistake is flooding the chainsaw. That occurs usually when the saw is already hot and we put it into full choke mode, trying to get that pop. If it's already hot, we just go to a half choke, hot start it, and we're ready to work. For whatever reason, if we do put it in full choke and we pull more than 5 pulls, I'm thinking flood. I'm thinking we've gone beyond the point. I would put it in half choke and just start pulling, and hopefully we can get the saw to start. For whatever reason, we've flooded this saw with too much fuel. We need to fix that problem. So how we fix that problem, I'm gonna intentionally flood this saw right now. So I put it in full choke. Now I'm gonna give it a good 15 pulls approximately, and then I'm gonna unflood it. So full choke. That's 15 pulls. It for sure is flooded. So the way that I'm gonna fix this problem, I'm gonna put it in half choke. So one up click, I'm in half choke. Chain brake off, and all I'm gonna do is I'm gonna keep pulling until I get this saw to start. For me, this is the best way to remove the choke. There's other ways by holding it down, opening up the throttle, one person holding it that way, the other person pulling. That's another method. But for me, this method works pretty efficiently. So half choke. You can notice by the coloration of the exhaust, it has like a bluish white color to it. That's a symbol that your saw was flooded. It's just burning off all that extra fuel. And why I leave it on high idle and let it run hot. You can either let it run, hot start it and let it run, or click it onto idle and then keep it on full throttle, 10 to 15 seconds. I'm trying to burn it all off. If you get it to hot start and then you click it into idle, it'll die again because you still have a lot of fuel in there. So you need to pump all that fuel out and then you can set it into idle and then go to regular operations. That's how I unflood saws. So we could start the saw in idle position. So just click down one and we're in idle or run position and we start the saw. This saw is running nice, but if this carburetor is not adjusted correctly or there's some type of internal issues, what could happen is the saw will end up dying out when you give it throttle. So I start to give it throttle and it bogs out, whoa, and it dies out, right? That's a common issue. It's not hot enough, that's the problem. So I personally always start my saws on half choke, hot start, so that I can get it to that temperature that it wants to work at, and then I'm ready to go to work. If you do it at idle, most likely your motor's not at the perfect temperature that it wants to be at, and then you have to get your motor to slowly climb up the ladder. So by hot starting it, you get it right to where you want to go, where you want to be, and then you can get on with your operation. My sawyer here is operating the saw, and I need to get a hold of his attention. I want to touch him on the trigger hand side. The trigger hand side, if he turns towards me, the bar is still a good distance away from me. I'm away from the hazard. If I touch him on the other shoulder, away from the trigger hand, the bar, when he turns on natural reaction, the bar is in my general area, creating a hazard. When operating a chainsaw and your partner here needs to get a hold of you, touches you, let your saw idle down, wait for it to idle down, apply the chain brake, and then turn, holding the saw away from the partner. Talk to him, take the chain brake off, go back to work.